Dear students, in this video I will explain about Gay-Lussac's law. Okay, means Gay-Lussac's law of combining volume and Avogadro law. This both law is present from the chapter mole concept and stoichiometry, and most of the parts has already covered what is relative atomic mass, what is relative molecular mass, what is percentage composition. That you already have some idea from the previous classes, and you already learn about the gas laws, means Charles law, Boyle's law. You already learn what is gas equation in class 9, already you have learned. So here another two gas laws which is applied only for gases, okay, only for gases, that is Gay-Lussac's law and Avogadro law, not in solid and liquid. Okay, so from the gas laws we will learn this means learn these two, another law, Charles law, Boyle's law, already you know. So today we are starting Gay-Lussac's law. So Gay-Lussac's law is what? Very easy, students. When gases react, they do so in volume. Okay. So when gases react, they do so in volume, means which bear a simple ratio to one another. So it's better to take an example, then you can easily understand. Suppose hydrogen, it is valid only for gas, already I told. Suppose hydrogen react with chlorine, okay, and form 2HCl. That is gas, that is gas, that is also gas. Okay, so one volume we can see that first you have to balance the chemical equation. You know why need to balance? Because number of reactant and number of product, and it will total, the law of mass action will valid. That's why we need to balance the chemical equation. Okay, means number of the quantity of reactant and quantity of product should be equivalent. Okay, so that's why if you balance, you can, as it has balanced, you can say H2 plus Cl2 2HCl. Okay, so hydrogen react with chlorine, form 2HCl. So after balancing, you see that that one volume, if I say one volume of hydrogen react with one volume of chlorine, produce two volume of 2HCl, means two volume of hydrogen. That means, I think you understand, means all under all similar condition, means pressure, temperature, okay, all should be constant, pressure, temperature. Okay, then when gases react with them, okay, they do so in volume. Okay, means when all other conditions are all other similar condition, you can say like that. Okay, in all other similar condition, when a gases react, okay, so they do so in volume, their volume also remain constant like this way, means one volume react with one volume to form two volume of hydrogen chloride gas. Okay, so suppose if we come to the in a value, here I just simply write one volume, two volume. So if it will come that, suppose 100 ml hydrogen react with, then one volume hydrogen, means react with one volume, means if it is 100 ml, it will be also 100 ml, and it will form 200 ml, two volume means 200 ml HCl. Okay, similarly if you say 50, then it will be 50 and it will be 100 ml. So that is the simple thing of Gay-Lussac's law, that when gases react, okay, they do so in volume. And he observed that thing by using the experiment of hydrogen and oxygen. Okay, hydrogen and oxygen during formation of water molecule. Okay, mm, means water vapor, okay, not liquid, water vapor, H2O. Okay, so then he generalized the law of combination of volume, simple addition of volume happens. Okay, similarly students, if another one example, if I suppose burning of methane, suppose CH4 burning in presence of oxygen, it is burning, mm, carbon dioxide and water will form. You know, burning means anything burn to form carbon dioxide and water vapor. So students, suppose given, suppose that is a question I am saying, that methane is burning, CH4 methane is burning, burning of methane gas, which is 100 ml, or suppose 100 ml methane is there. Okay, how much oxygen required, how much O2 required? Okay, how much O2 required and how much CO2 formed. O2 required means reactant, so it how much required and how much formed of carbon dioxide, that you need to calculate. So students, you can see its volume has given liter, milliliter, this is the volume. So simply all other conditions are constant. Okay, similar, all other similar condition. Okay, then first we will balance. See, it is not balanced. So how it will balance? So we put 2 over here, 2 oxygen, then carbon dioxide plus 1 1, you see that 2 to 4, 2 to 4 oxygen, then hydrogen 4, hydrogen 4. How to balance? By using applying atomic theory and all ABCD, all methods. In previous class, previous year also I explained very easy method to balance a chemical equation. I hope you can do it. Okay, it's very easy. And one another method to for balancing, I told first balance the metals, then non-metals, then oxygen, then hydrogen, like this way. Okay, so students, I hope you see carbon carbon 1 1, hydrogen 4, then oxygen 2 to 4, 2 to 4 oxygen, then hydrogen, completed balancing. Now you can write like this, that one volume of methane, all in gas, gas, but here water form is liquid. That's why water we will not, means Gay-Lussac's law will not apply for water. So one volume of methane react with two volume of oxygen, form one volume of carbon dioxide. Now you understand. So 100 ml of methyl has given. That means 100 ml of methane, how much oxygen required? 200 ml. Okay, I think you understand. 100 ml means it will require 200 ml oxygen and it will form 100 ml carbon dioxide. I think you understand. So how much oxygen require? 200 ml oxygen require. And how much carbon dioxide form? 100 ml carbon dioxide form. And if for this it is liquid, hence Gay-Lussac's law will not apply. So we can easily calculate the volume of the reactants and the product, what in gaseous states. So that is the importance of this law. Okay, how the reactants are reacting, their volume ratio, simple volume ratio, and the product also, there is a simple relation has given by this scientist. So students, if I give another example, you need to solve some numericals, then you can easily understand this law. Suppose suppose 60 ml nitrogen react with 60 ml hydrogen to form ammonia. Okay, 60 ml to form ammonia gas. Okay, so just I am explaining first, form ammonia gas. So how this law is applying on this equation? So write the equation: N2 plus 3H2 2NH3. So one volume nitrogen, all in gaseous, ammonia gas is producing. Okay, so all in gaseous, so one volume nitrogen, suppose means students, 60 ml nitrogen react with 60 ml hydrogen, how much ammonia will produce? Okay, that I am explaining. So 3 volume, 1 volume of nitrogen react with 3 volume of hydrogen to form 2 volume of ammonia, all in gaseous condition. So Gay-Lussac's law valid. Now student, it has given 60 ml nitrogen, you write here 60 ml. So how much hydrogen needed? 60 into 3, 180 ml. But here you see only 60 ml hydrogen has given. Only 60 ml hydrogen has given. That means I hope you understand that uh, total amount of hydrogen is very less. Okay, amount of hydrogen is very less. That's why hydrogen is also known as limiting reagent, means it will completely vanished, means it will completely used up by the reaction. Okay, so 180 ml as he has we need 180 ml, but it is not possible, because not possible this reaction, because whole 60 ml nitrogen will react when 180 ml hydrogen will be present, but it has said that 60 ml hydrogen has given. So it is this type of, from this side we will not calculate, so this calculation is not possible. We will calculate from hydrogen sides of view. How, student? You see, 60 ml hydrogen has given, that means 60 ml hydrogen has given means 60 ml means 3 volume hydrogen react with 1 volume nitrogen. That means 60 ml divided by 3 means 20 ml nitrogen is needed. Okay, here excess here you see hydrogen completely used up, can used, but nitrogen given in excess. Okay, so from this side we need to calculate, not from right side. From nitrogen side we will not calculate, we will calculate from hydrogen side, because hydrogen is the limiting reagent. That's why from hydrogen side, hydrogen is 60 ml. Okay, so for 60 ml will completely react with 20 ml nitrogen, because see, 1 volume nitrogen means 20 ml nitrogen react with 20 into 3 60 ml hydrogen to form 22 volume, means 2 into 20 means 40 ml ammonia. I think you can understand. I think now you can understand. So there is a unreacted ammonia will be there, sorry, unreacted nitrogen will be there, because 60 ml nitrogen has given, but for reaction we need 20 ml. That means 60 minus 20 means 40 ml unreacted nitrogen will be there. Okay, in the reacting chamber, unused 40 ml nitrogen gas will be available. Okay, so only 20 ml nitrogen will react with whole 60 ml hydrogen to form 40 ml ammonia gas. Okay, so these types of question will come, that value will be given, volume will be given, one percentage will be given, this percent, that percent, lots of example has given in your book. So one or two example I will another two example I will do here. So then the numericals related to Gay-Lussac's you can solve very easily. Students, one example has given in your book, already it has solved, but if I explain it will be better for your understand. So here given that this type of reaction has given, okay, that methane burning or react with chlorine. Okay, methane react with chlorine to produce methyl dichloromethane and 2 HCl gas, all in gaseous states. Okay, so that 40 centimeter cube volume has taken in centimeter cube, it has given, you know, 1 liter milliliter. Volume will be measured in these units. Okay, 1 liter is equal to 1 decimeter cube. Okay, so here 1 milliliter is equal to 1 centimeter cube, like this way. So students, here here the question is this, that how much chlorine required and HCl formed. Okay, previous I have solved one question like this way. So here first write the equation, already it has given, balanced equation will be given in the question, then to very easy for you. So 40 centimeter cube has given, so first we will write, you can see 1 volume of methane react with 2 volume of chlorine, produce 1 volume of mm, one volume of dichloromethane and 2 volume of HCl gas. So how much 40 centimeter cube will react with how much 46 centimeter cube react will produce, need 2 into 40 centimeter cube means 80 centimeter cube chlorine. Okay, 80 centimeter cube chlorine will need, and it will produce, so chlorine require is 80 centimeter cube and it will produce 2 volume means 2 into 40 centimeter cube means again 80 centimeter cube HCl. So that will produce, so when methane react with chlorine it will produce 80 centimeter cube HCl will form or produce, and required 80 centimeter cube chlorine. Okay, chlorine gas 80 centimeter cube required by using the reaction. Okay, by using the chemical reaction formula we can easily calculate it, how much volume gases is needed or how much volume gas will form. Students, one another law I told, that Avogadro's law. Okay, so Avogadro's law is there, which is your Avogadro hypothesis, you can say that under similar condition, equal volume of all gas have equal number of molecules. So what is Gay-Lussac's law? When gas react, they do so in volume. Okay, and for Avogadro is saying that if all under similar condition means temperature, pressure, okay, that all will be remain constant, then what happened? Equal volume of all gas have equal number of molecules. Okay, whatever the gas will be there, it should be equal. Suppose it is a 100 ml, it will better to experimentally I will explain with the example. Okay, suppose 100 ml chamber, both container is same, means volume is fixed, equal volume of all gas. Suppose here we are giving nitrogen gas and here we are giving hydrogen gas, we are filling with hydrogen gas. So under similar condition, 100 ml nitrogen gas, 100 ml container, if a nitrogen gas, here the number of molecule is x. If number of molecules means n, you can say, okay, means V proportional to n, simply you can say that if number of volume, equal volume means 100 ml contain x number of molecule, here also number of molecule will be x. Okay, x. So that means you understand, under all similar condition, you just students, these two hypothesis, two law applied only for gas, and these are very easy. I hope you can understand. Okay, means very easy. See, under similar condition here, when gas react, they do so in volume. Very easily we can calculate the volume of reactant and product if there is if that is in gaseous medium. Similarly, students, under similar condition, whatever the volume of gas will means equal volume of all gas have equal number of molecule. Okay, that means that gas will be whether nitrogen or hydrogen or whatever, but their molecule should be same. Suppose if I give an example, that suppose under similar condition, there it is, suppose 60 ml hydrogen. Okay, hydrogen has x molecule. That means 60 ml carbon dioxide also have x molecule, 60 ml sulfur dioxide will have x molecule. Now students, 120, suppose 120 ml, then 120, suppose 120 ml nitrogen, then how much it will, 60 means 60 into 2, that means 2x molecule. Okay, similarly if I say 30 ml of nitrogen, then you can say 30 ml means half, means x by 2 molecule. Means there is a simple ratio between number of molecules if the volume is equal, and volume is equal, then means 60 ml nitrogen should be x, 60 ml nitrogen is x. Okay, under similar condition, temperature, pressure, all other condition similar, okay, condition, then you can see equal volume all gas have equal number of molecules. So if 60 ml contain nitrogen x, 120 ml will contain 2x, and 30 ml will contain x by 2, x by half number of molecule. So that is the you can say that that is the simple ratio. Similarly students, if under similar condition, means temperature, pressure, all other, if I say, I'm just explaining with example, because you can, then you can easily write in the exam also, or you can remember that. So under similar condition, suppose student 50 ml hydrogen contain y molecule, then 100 ml carbon dioxide will contain 2y molecule. Under similar condition has given, so you understand 100 ml means double, means so 2y molecule. Similarly student, if I say 75 ml carbon dioxide, then student how you will calculate? You will calculate like this way, that 50 ml carbon dioxide means y molecule, so 1 ml y by 50, and 75 ml will calculate y into 75 by 50, 25 3, 25 2, means 3y by 2 number of molecule, 3y by 2 number of molecule. Means simple numerical maths, by using unitary method you can calculate. Okay, so if 200 ml Suppose methane has given 200 ml methane under similar condition, so 54 times means 4y. If it will come simple whole number multiplication, then you will write that y 2y 4y. But if it will not come in simple whole number, you will using the apply unitary method to calculate it. Okay, so students, I hope you understand. This is the Avogadro law and Gay-Lussac's law. Thank you.